first of all, of course, welcome, and thanks a lot for taking the time. Now, so what is SiPearl at all? Am I pronouncing it correctly? It's SiPearl?
Let's say SiPearl. It looks
SiPearl,
like,
okay.
let's say wider.
So what's in the name
scope.
then? Like, so why is it called that?
Silicon. Because
Okay.
we are a semiconductor fabless company, so we develop silicon chips.
Right.
And Pearl, because I like the concept of the black pearl, this kind of pirates, rebels, so they had to fight to survive, and that's the way we work, trying to be innovative in front of big giants, which are usually in US for what we are doing.
And what SiPearl do then?
So we are a semiconductor fabless company. We develop our core product. It's a super high performance microprocessor targeted for supercomputing, data center, and inference AI. So which is the masterpiece that will do most of the computation.
And you started how long ago?
The company started in 2019, the first employee in January 2020.
Okay.
And it took me, let's say, 2017, 2018, 2019 to incubate the company, part of an H2020 project. So we have a link with Brussels, which is quite strong.
And what did you do yourself before doing all this?
I have, let's say, more than 25 years of experience in the semiconductor. It was mainly consumer business, audio, video.
Right.
Before setting up SiPearl, I was in Atos as general manager of European Processor Initiative, which is an H2020 consortium. And SiPearl is the first industrial baby of EPI. Before this, I was the head of the consumer division in ST Macro. I had more than 2,000 engineers. And before this one, I spent close to 9 years in a Taiwanese company, which became a tech superstar in Taiwan, named as the MediaTek.
Okay. But you so you say that your product is a microprocessor, but at the same time you are not in the business of manufacturing microprocessors, right?
We are designing.
Right.
And we are fabless. The first fab is in Taiwan. We would like to produce in Europe, but there is just no fab at this level of technology in Europe. So
as in like this level of like 5 or 6 or 7 nanometers, whatever it is.
You got the point. We started in 6. We are now moving to 3 nanometer.
Okay.
So which means that the fab, it's either TSMC in Taiwan, could be Samsung in South Korea, or new fabs which are opening in US.
Right.
Not in Europe yet, unfortunately.
So in this, you are somewhat similar to what ARM does, for example. So is it the same model or is it still different?
ARM is one of our main stakeholder, investor, partner. The processor we develop is based on ARM technology. So we are using their ARM core, so-called V1, V3, to build it. Because to have a microprocessor on the market, you need an instruction set which is well known. So today it's either x86, what Intel AMD are doing, or ARM, which is really taking off very, very fast in the data center.
Yeah. Well, technically you have RISC-V as well.
Not deployed yet. Let's say it will happen, but still not before 10 years. It took ARM 10 years to do something serious in the data center. Now they are scaling up quite fast. And something like, I guess it was on Bloomberg this morning, something like 50% of the new servers in the data center switch on are now ARM-based. So it's really the ARM time, and we are quite happy to arrive with a solution which is ARM compliant.
Is this your market as well, data centers, or are you solely focused on supercomputers, HPC?
We started on supercomputer. We'll be deployed next year in the largest European supercomputer, the Jupiter machine, which will be in Jülich in Aachen in Germany. We expect, of course, to be deployed in other supercomputers in Europe and beyond. But for us, that's not sufficient. We need to scale up to have, let's say, more volume, more revenues, and data center, and especially inference for AI is much more wider in terms of market.
Is SiPearl the only company doing this in Europe? Is it going to be the only domestically designed supercomputer processor?
At developing CPUs,
yeah,
we are the only one. After you have a couple other companies working on accelerator, RISC-V based or others that were happy. We know them and will be happy to be deployed on the same machine. But in terms of CPU at this level of scale, it's just competing with the US players, you know.
and how well do you think you can compete against those like bigger, mostly bigger companies?
If EIC keeps on supporting us, if EU keeps on supporting us with extra order, etc., we are not at the same level of scale budget. That's for sure. But let's say we are learning. Now there are some big changes in the European tech versus US tech, so we expect to be part of it.
Right, I understand. So, and I mean, the industry that you're working in, semiconductors and CPU design, it is very important for the sovereignty, for technological sovereignty of the European Union, something that is being talked about a whole lot. And with that regard, a question: would you consider selling the company to a US acquirer or corporate if the price were right?
That's a bit tough. I cannot answer here in front of the executive from EU. No, it's not an option today, because we have built a sovereign project. We need to have the control of the company in Europe. We need to limit as far as we can the exposure to US export rules and to the fact that the US administration is trying to control everything. If not, we lose our DNA. Now, a fact is that there are just not enough money, equity in Europe to scale up. So we'll need, let's say equity coming from other places.
No, I understand. And in a recent interview that I read, you mentioned a hypothetical European Buy Act. So what is this? What did you mean by that, and how would it look like in your view?
A European Buy Act is just the European translation of what happens in US for 80 years, what happens in China and in Japan for decades. Is that when you have, let's say, local order, or let's say public order, so public money looking for technology or product, you need first to buy local technologies. That's what US is doing. They are just protecting their technologies. And a good example is the services, data services in public cloud. And Switzerland, it's a very good example. They announced a couple months ago now, part of Trump effect, etc., that Swiss public cloud services will be hosted in Swiss cloud and no longer in US cloud. That's a good example. And also there are plenty of public services at European level or member state level. They should only use, let's say, local cloud, I mean pure European cloud. And this is not American cloud in Europe, it's pure European cloud, Second Cloud, UCS, etc., to ensure that this stays in Europe and to create local values. After chicken and eggs, because if we keep on spending public money, like for instance the 300 billion which have been announced for data center, 109 for France and 200 for Europe. So if this money is just spent in buying some US components, it's just a waste of resources. That's what happened 20 years ago in the internet days. Where let's say we had plenty of very interesting internet startups in Europe. What they did with the money they raised, they bought some Google AdWords, so Google advertising, so let's say some web services in US, some cloud services in US, and this money went back there. So this money has to stay here to create value, to create jobs, etc. And that's what the European Buy Act should.
I mean, Switzerland is really interesting. They're doing that, and then I also remember that they at some point stated that all the government software should be open source as well. Like whatever government is using should be open source, just because it's public good, basically. So it's an interesting example that we probably all can follow.
And Canada is trying to do the same.
Canada as well.
Good example. Same for defense. So Ursula von der Leyen, she announced something like 800 billion euros for defense. Is it to buy some US military components, or is it to buy local and to create value, to create jobs, etc.? So it's really time to have a very good wake-up call, and we can thank the American and the administration Trump to help us on this.
And for you, are you? When do you think you haven't started delivering the processors yet?
No, not yet. We are sampling. Let's say it's going to production soon. We'll sample and let's say early next year to be deployed in this Jupyter machine first.
Yeah,
it's a very long cycle, and when you are a semiconductor fabless company, the first chip is very, very complex to cook.
But then it's going to be easier after the first one.
After finding the good money for it, etc., it's going to be easier because the team is now kind of trained. we had to build a team. We had to fulfill, let's say, some European rules because we wanted the R&D to be mainly European to limit export issues. So this takes time, and we are about to ship the largest semiconductor project in Europe also.
Yeah. And speaking of the team, how many people do you have in the company? How many people do you need?
Yeah, we are close to 200.
Okay, that's sizable.
That's a good experience of scale up, yes.
Yeah. And you're all based in France then?
France, Spain, Barcelona, opening Italy as soon as we have some, local support and local investors.
Right. And I have a question that is a bit different. So it's a bit like going beyond semiconductors and deep tech. So it seems like Europe is doing okay-ish at this point with deep tech and this like very foundational kind of things. There's EIC that supports companies working on all that. But then I guess if we want like true sovereignty and true strategic autonomy, we also need to have the consumer level platform, consumer level infrastructure. So basically the European Facebook, the European Twitter, the European Google, the European Amazon Web Services, whatever you can think of. So what do you think is actually going to happen? Do you think it's like the realistic thing at all to think about?
It can happen. You have a good example with Mistral.
Yeah,
it's a European player, so competing with forgot the name, the OpenAI. Yes, or you have Aleph Alpha in Germany, etc. That's an example. From time to time, it happens. They got enough money to grow. They got lots of public intention, so it works. EIC is a very good tool to start to seed some deep tech startups. The problem is for the next steps and to ensure that when you want to scale up and work on, let's say, round size, let's say beyond 100 billion, that this will happen in Europe. Because a way to see Europe and to see the EIC ecosystem, in US they like it because it's a kind of incubator. It's cheap because you can develop a concept for 4 times or 5 times cheaper than in US because the salaries are in a different level. And if it crashes, it's not a big deal because they have not lost lots of money. If it works, yes, it's time. It's serious time. They need to send back this company or this concept to US, and that's what we need to avoid to ensure they can stay in US. They can stay in Europe. Sorry.
Yeah. And you probably, also I wanted to ask about the entire generative AI hype cycle that we are going through at this point. So do you feel it in your industry? Do you have a use for it? Do your semiconductors, can they be used for inference, for example, and training with AI companies? So like, what's your relationship with that industry?
You mean to use AI tools for own design?
Yes, so both, yeah. So do you use AI tools in your work, and then can your semiconductors can be used for inference and training?
We start to implement this in the R&D because the way to design a chip called development flow is changing. It's slow because we are not developing the tools ourselves, but the tool providers such as, let's say, Synopsys or Siemens Motor are introducing this or we're using this. It's clear that in the next 5 years, an R&D to design a chip will be drastically different than the one we have today.
Okay.
For instance, the way you have to route a chip and have all the tracks, etc., it's getting very complex on this kind of design, so you need lots of AI help to do it. And the design flow is also very slowly moving to GPU use. Today, we have developed our own data center. We spent more than 20 million euros to have our own compute farm because we wanted to be far away from the US Cloud Act. So the best way to do it, and with very specific needs in terms of memory, etc. So we develop our own data center. Today it's CPU based, and we know that in the next years we'll have more and more GPUs in the data center for this kind of design. But it's a bit slow compared to the adoption of AI, let's say for generative AI, etc. Now, the chips themselves, and the first one we have, knowing that it has lots of embedded memory, so-called HBM, can be quite compelling for inference. Not for machine learning, which is really the NVIDIA stuff today, and AMD, which is catching up quite well. But for inference, there is a huge market, which is going to be 80% of the AI market, and that's the one we have to focus.
Right, I understand. Now, Philippe, thank you so much for answering the questions.
You're welcome.
Also, very nice socks. I'm going to film them in a minute.
Yes.
It's quite amazing. Wow.